everyone. Welcome to Being a Product Manager in Networking and AI Infrastructure, hosted by Product School. I'm Bhuvi Chopra. I'm a product manager at Google, where I have been leading projects at the intersection of hardware strategy and AI infrastructure. My work has earned me some recognition, including the ISEP Excellence in Service Innovation Award for my work at Cisco. I'm really passionate about empowering women in tech and business, and I'm an active associate with initiatives such as Forte. I've been honored as a Women of Impact for this year as well. On an academic side, I have an MBA from Washington University in St. Louis with a Bachelor's of Science from Delhi College of Engineering. This mix of experience gives me a broad and a unique perspective of work. Thanks for having me here. So the agenda for today is we'll just do an introduction of the topic, dive into the basic of AI infrastructure, double click on networking and connectivity, talk through some of the challenges and considerations in this industry, followed by future trends in the industry, and some of the best practices for product managers in AI infrastructure. So what is the AI infrastructure, right? AI infrastructure basically refers to the foundational technology and system that supports the development, deployment, and operation of AI applications. So this includes both hardware, including data management and networking, as well as software. Why is AI infrastructure important then? So as the size of data sets keep increasing, the performance scaling, which is crucial, of ML models to have started hitting a peak before experiencing performance bottleneck or lag. And that's why this is super important. So number one, AI infrastructure is important because it enables advanced capability, such as supporting some of the more complex AI models and algorithms, as well as facilitating some of the large scale ML data sets, as well as processing and analytics. Number two, it's important because it enhances reliability and security. So it ensures a robust fault-tolerant system, and it protects sensitive data and complies with regulations. And third, it ensures performance and scalability. So it provides computing power, which is necessary for real-time AI application, and it allows for seamless scaling of the AI solution as the demands grow and have started reaching exponential level. So why is it really important for product managers? Is number one, AI infrastructure is the basis of competitive advantage. So AI-driven features have started differentiating themselves in the marketplace based on the performance, and performance is directly linked with the platform on which these ML models have been running. It accelerates innovation and time to market in that perspective. Second, it helps in strategic planning and cost optimization. So you're able to make informed decisions because cost is a crucial factor when it comes to AI infrastructure. So you're able to balance and find an optimum center point where you understand how much performance you need to meet and what is the cost behind supporting that infrastructure to meet that performance. And second, it helps from an operational efficiency. So it basically helps you understand, all right, do I need to foreplan and change the infrastructure and able to attain that operational efficiency needed for the ML model to be able to run? Or do I need to find another way of increasing the existing server and hardware's life cycle to maximize on the performance that is needed? Next, let's talk about basic of AI infrastructure. So the AI infrastructure consists of hardware, data, and networking. In hardware, you've got the CPUs, which are central processing units. And then you've got the GPUs, which are graphic processing units, right? Now, since the 1970s, CPU units introduced by Intel have been the brain of any computer or computing device. CPU units have perform these operations without any speed or performance bottleneck, be it any logical, computational, or input-output operation. Especially, CPU technology was designed with a single core to perform a single operation at a given point of time. Gradually, With technological advancements and higher computational needs, we begin to see dual and now even multi-core CPUs that are designed to perform more than one operation at a single time. Most CPUs today are built using a few cores, and their basic design is still primed for solving a few complex computations. Now, like CPUs, GPU is also used in any computer or to process instructions. The significant difference when it comes to CPUs and GPUs is GPUs can work on multiple instructions at a single given time thanks to parallelization. Most GPUs are designed with many processing cores with clock speeds that are much lower than those of CPUs. Next is data storage. So, storage is definitely important because that's where the data is hosted for the ML models and solutions for keeping a vast amount of data accessible and secure. So, storage forms a crucial part of the AI infrastructure. And third is networking, which is the space where most of the companies and cloud providers are differentiating themselves, which is connectivity and low latency. So high speed data transfer and communication is important, and effective movement of data across system and location is definitely super crucial for ensuring the optimum performance of the ML model. So next, let's double click on the network and connectivity part of things. Now, building infrastructure for AI servers is not a trivial game, especially in networking. It requires large investments and engineering to minimize latency and maximize connectivity. AI infrastructure has definitely made traditional enterprise and cloud infrastructure look like a child's play. Now, there has been a surge in companies contributing to fundamental infrastructure of AI application. The giant in this space, obviously, is NVIDIA, which has the most complete infrastructure stack for AI, including software, the GPU chips, DPUs, which are data processing units, and smart NICs and networking. So one of the ongoing discussion is the role of InfiniBand, which is a specialized high bandwidth technology frequently used with AI system versus the use of Ethernet. NVIDIA is perceived to be a leader in InfiniBand, but it also has hedged by building Ethernet-based solution. So Ethernet advantage is definitely more economical, but it also requires software tweaks and coupling the Ethernet solution with smart NICs and DPUs. Now, you definitely have industry-leading companies such as Broadcom, Qualcomm, Arista, Cisco, HPE, which are predominantly playing in this space. So high-speed connectivity is important because it ensures fast data transfer between the system and reduces latency, especially for real-time AI application. So real-time AI application could be, imagine, a McDonald's or a Vendy drive-through where you're actually placing an order using the interactive AI point of sales machine, and then you need to make the transaction there and then, and you want your order to be placed in real time. So this is really important for such applications, as well as autonomous vehicles. Now, the technology, as we were discussing, is basically your smart NICs or your InfiniBands or high bandwidth network. And another important concept is distributed computing. The distributed computing consists of edge computing, cloud computing, and hybrid model. In edge computing, data is processed closer to the source, which reduces latency. So that's one way of actually achieving high connectivity. This enhances performance for real-time processing, such as IoT devices, the point of sales example that I shared, an autonomous vehicle. Cloud computing, which is your traditional Google Cloud, AWS, and Azure model, is centralized processing, power, and storage. It's a scalable and flexible solution and definitely less expensive than your edge computing model. And third is your hybrid model, which is a middle ground between your edge and cloud computing, which combines edge and cloud computing for optimal performance. It balances processing load between the load and central resources. Examples of this are smart cities, connected healthcare system. Now let's talk about some of the challenges that are happening in this space because it's up, new, and definitely an exciting space to be in. But there's some challenges that the industry is definitely facing. First, it's scalability. So managing the growing volume of data and increasing computational demand has always been a challenge. You need more space to house more storage devices, more hardware devices such as servers, and that has been a challenge. Second is security. How do you protect sensitive data and maintain compliance with data privacy regulation? Responsible AI does not just happen at the application layer. You need to ensure that data at rest and data in transit is also encrypted. And that's where responsible AI comes into the picture for platform layer. Cost management. Balancing the high costs associated with AI infrastructure is definitely a challenge. Interoperability. Integrating AI infrastructure with existing IT systems and workflow is definitely been interesting because some of the data centers are traditional. They are used to supporting lower power. Whereas with these high powered sucking machines, GPUs and CPUs, you need more power, you need a different type of infrastructure, you need more space. So that has definitely been, and interoperability has been a great challenge. Accuracy, so ensuring accuracy, consistency, and reliability of data, which is being used for AI models, and also ensuring that your storage devices, your networking devices do not actually just stop and provide some sort of downtime to the performance that is needed for ML model. Latency, which is really important, reducing the time delay in data processing and model interference. Responsible AI, which is navigating the ethical considerations and regulations requirements related to AI usage, such as also making sure that the data that's coming in is encrypted, making sure that it's actually meeting the standards and the compliance. There are security standards devices need to meet, and that has to be ensured. Environment. So with all of this development, there's obviously an environmental footprint of AI infrastructure, and that has definitely been a concern in this industry. Innovation. So every 6 months, NVIDIA comes out with a new GPU, almost a new GPU, and Intel comes out with a new CPU. So it's really important to keep up with the pace of advancement in AI technology and infrastructure. So what are the future trends in this industry? So first up is definitely confidential computing. So confidential computing is basically, as the name suggests, right? This is the responsible AI area where you're trying to make sure there's encryption of data both at rest and in transit. And confidential computing now takes place both at your GPU and CPU level. So you're making sure that the data that's being processed is encrypted within a server, right? And this has been a very important concern. NVIDIA is definitely ahead in the game for this. But also Intel has offered its Intel Xenon processors, which ensure this, the 5th generation, the 6th generation. Confidential mesh is when you're trying to use different levels of GPU, right? Different generation of GPU. And now when you have different generations of GPU, you're trying to have some sort of data processing across different servers. And in this case, you are offering confidential mesh. This is a new and upcoming field. Quantum computing definitely has potential to revolutionize AI by solving complex problems faster with classic rather than your classic computers. Predictive maintenance. Now, this is super important because this is essential. And as I was mentioning, you cannot have downtime in your AI infrastructure because that impacts your performance. So now your traditional companies such as Cisco, Palo Alto Networks are finding ways where they can embed AI into their devices and actually let the AI infrastructure lead or the data center lead know that these devices would need maintenance. And that's where Cisco and NVIDIA have recently also announced a venture. Sustainable data center is where you're trying to get liquid cooled data centers, they're actually, instead of having air circulate and air conditioning circulate, as well as having high energy air conditions, you're actually using liquid for faster cooling and for renewable resources. Cloud centric to edge centric has definitely been an important one, where there has been a shift towards processing data closer to the source rather than relying solely on centralized cloud server. This definitely helps in reducing latencies and bandwidth usage, improves real-time data processing. And then last one is federated learning, which is definitely a new one. In this sense, what's basically happening is you have your AI models and you are breaking them down in the sense that now you would have different processing being done by different GPUs. So instead of just one server doing your learning, you have multiple servers in a cluster that form an intercluster, and they're actually trying to come up with your training and inference use case. Now, this is definitely the place where training AI models across decentralized devices comes in, while maintaining data privacy, which is really important. Now, this impact for this is going to be enhances collaboration without compromising data security. So, what are some of the best practices for product managers in AI infrastructure and networking? Because this field is continuously developing, it is important to keep up with the pace of innovation to understand what is the latest GPU, CPU, or the next generation of data center requirements that are penetrating in. So it's definitely important to keep learning. It's important to strategically plan for the AI infrastructure, because this is not something that can be spun up at the end. You need to have a strategic plan. It could sometimes even take years for the IT administrator to build up this sort of infrastructure. If you're looking for an edge computing case and you want all of these computations to be in-house closer to the source. So time is definitely important, and it's important to take AI infrastructure into account. Third is resource allocation. So as a product manager, you're responsible for the P&L, profit and loss of your product, and ROI. So it's important to look into the cost, time, money, as well as manpower resources that are needed to actually bring up the AI platform, and risk management. This is definitely important. So I would say the key learning is now you have, number one, a clear understanding of what AI and networking infrastructure is. Next, you understand what scalable, secure, and performance optimization means. And third, what does it actually mean to be a product manager in AI, and what are some of the essential skills? To double click on some of the skills, I would recommend following some of the other sections at Product School or taking up some certifications. Thank you.